Hello everyone, this is Ali Reza. We are continuing our reflection node. Now, I think the getting field value is very close to this guy. So let's copy it, but instead of getting properties, I will get fields, okay? And what did I do? No, that's not there. So if get field with the string is that, or get, well, let's copy it. Get field with the name, well, can read doesn't mean anything, so because fields are always readable and writable. Then get field, get value, but we don't have any null. That null is a second parameter. If you look at here, is object array indexing. Well, on properties we can have indexing, on fields we don't have indexings, so that's that, and basically that's it. Now we have our get field value. Now setting is almost the same, but when I want to create, I need to do I need to do it differently now. Let's first take a look at reflection. Set field C# and set value. Also on property. So setting a property by return with a string value. That's exactly what I want. So ship is the object, get type, get property that, then set the value that, okay? Let's see. So else is the property, so bam, ship is object, get the property with the, come on, get rid of that. This is our member name. Then let's say dot, we need set value directly here. And I forgot something. When we are setting something, we need the value. So I will say serialized field, public, again, object, value with capital V. So that's the value that we want to set, okay? So ship again is object. And let's import that. The value is the one that we sent in. Property info dot property type. Now, property info is this guy. So I will select it, Ctrl+Shift+R to introduce variable, and that is all occurrence. Oh no, I didn't want that. Wow, that was stupid. So Ctrl+Shift+R, introduce variable, once occurrence, there we go, property info, and that's it. That null, the last value, is again the indexing, okay? So We get the property with the name. Now we need to say that again. This guy, we need to do stuff, then back. So if object get property with that name equals null, or can't write, so we don't have this set method this time, then we basically are in the same state. So we error out and we return. Otherwise, we get the property, we are sure it's not null because we checked it, then we set the value on the object and we convert the object value that we sent in to this property type. That's how we change the type, and then we set it. This is the value, okay? And indexing is always null. Now, let's copy this guy. And, well, before that, we have this. But now I need to do something in both cases, actually, not only on the set, but even on the get. We want a way to know that our metadata has this name or not. If we have this name, then we need to, instead of add, set it. So we say var data equals to metadata dot first or default t goes into t.name equals to this guy. Okay, so if data equals to null, then we didn't find it, do that. Else you say data dot set value as simple as that. Okay, so if we didn't find, add it and then set the value right there. If we found it, then well, we just go and set the value. So again, here we say var data equals to, and don't tell me that I can't do that, but we'll see if data equals to that dot first or default. No, I can. Okay, t goes into t.name equals to, again, the same thing. So if data equals to null, do this. Else, simply say data.setValue with value. So I now need to get this whole thing and paste it here, replace it with the other situation that we had, and in here again we are doing the same thing, okay, but instead of the value with the lower v, now we have the capital value. Okay, so there we go, and there we go. Now here is the thing, we may send in a component, okay, and a component is not convertible to an inline value. So if you look at the metadata, it's an inline value. An inline value will only accept Boolean, color, curve, and float, int, quaternion, rect, string, and vectors. Other than that, we can't accept anything. Okay? So here I will create a little helper method. So we say private that returns a bool can make inline value. We get an object, and we say if obj is well, what we want, bool, and I think we can do this. That is no. Okay, is bool, or well, instead of if we can say return object is bool, or obj is the next one, color, or obj is animation curve, or float. So obj is float, or int, obj is int, or was a string, yes, string. So obj is string, or a vector 2. No, I bypassed few. Okay, quaternion. So obj is quaternion, or rect, and then vectors. Obj is rect, or obj is vector 2, or obj is vector 3, or obj is vector 4. So if any of them, then yes, we can make inline value. And then when I'm going here, we say and can make the capital value here. So if the value is really acceptable by the inline value, then just do this, okay? And we will add it here, we will add it here, we will add it here, and the last one here. So if it's acceptable, and by the way, here we need to use lower v's. If it's not acceptable, what will happen? Nothing. Well, we just ignore it. We ignore that the user was derp enough to say, hey, cast this component to an inline value. Well, I can, you know, if I have my own serialization situation for binary serializations, then I could do something. But, you know, honestly, I don't see any other form of variable that would be used for any sort of node. And I'm not just talking about behavior trees. I'm even thinking about quest system or any other system that you want maybe later down the road. For example, skill system, perk trees, I don't know, whatever you want to use a node graph system for it. I don't see any other value type to be used for communicating between two nodes on the same graph, or for communicating between an agent handler and the graph. For example, what's the use of sending, I don't know, a transform here? What's the use of it? A transform has a position, has a rotation, has a scale, so we can break it down to 3 inline values if we need to. The transform itself, with all its methods, would be a very big overhead to be serialized as an inline value itself. We may only need its position, so we have a vector tree, and vector tree is here. And that is why I don't see any other, maybe in future, maybe we have long, maybe we have double, but for time being, int and float will handle it, you know. Most of the cases, I very rarely saw anyone having use longs and, you know, doubles for Unity gaming. That much precision. Well, maybe on some game for some, I don't know, food consuming, you would use long. But other than that, very few places you will use it. And you had seen how I handle things. So if you want to, you can really come back and inject long and a double. I may do it in future if we come to the place that we see we need it. So that's our set property. Now if I copy the whole thing, and by the way, if I finish this guy, we are just face to face with the invoke. So let's see, I want get field member is null, and field has no writing because fields are always writable. Then we say field info. So field info equals to get field, and then set value, and you see that field info dot what do we have here now? I think it's field type. Yeah, and we don't have the indexing here, and that's it. That's really it, and the rest is fairly the same. So actually I'm dumb, I can take this part, cut it, and instead of doing it both here and here, do it once. After the else, before the tick, here. And the same thing, oh no, here we can't do the same thing because one is the field value that we are getting. Yeah, we can't do that here. We are getting properties or fields. But on setting, we have one value, so we can do it once, okay? And what are you saying? Invert if. What would it happen? If not, no. Bye-bye. So now we are face to face with invoking a method, and we already saw examples of it. So here, reflection, invoke method, C#, and how invoke methods with parameters. So that's it. We have a method info, we have invoke. So how to get the method info? Well, let's take a look. Well, here is the thing. And we don't care about return type of any method that we are invoking, basically. Because here's the thing. In behavior trees, a node can return only one thing, and that is its evaluation state. It can set a flag on something, it can set an object. Well, let's do that. We say serialized field public object method result. Okay, and here we paste that method info equals to the object that get type that get method member name. So I will say if this guy is null equals to null, then we are again face to face with early exit on errors, like here. So we error and we return the tick. Otherwise, we invoke the method on, and instead of this, we have that method result equals to invoke the method on the object with now object array parameters. We have that parameters, but get member we have binding flags. Every place that we are getting something, for example get properties, can't we have the binding flags? I think we can. Get property with the name, type return type, get property. Yeah, here we go. We can use binding flags. Okay, so what did I do? So everywhere when we have these guys, we say binding flags, okay, and we have that flags that we can use. So let's use that, and with the flags, I'm totally lost, you know. This method is getting so much big. Well, here's the thing. If we invoke the method, then I will put this in try. I should do this try catch in many few other methods actually, but let's start from here. Catch without catching the exception. We just say state equals alert. Okay, if we succeeded, then we say success. Also, before returning anything, we set the state to success. We set the state to success. So we were successful in doing stuff. Okay, now coming from top, comma flags, and I will highlight that get field so that I know. Come on, why are you not highlighting it? Huh, stupid thing. Okay, there. And why are you not? Check expression for null. What I'm doing on top of that, for God's sake. For God's sake, I had done it, you know. Or field info. No, thank you. I already checked for the null on top. The repeating. So then we set the stuff with the flag, with the flag, with the flag. Now I know something is very bad here. I'm calling reflection after reflection after reflection, and reflection is slow. But I will come to this guy and optimize this guy in a few minutes after we finish this. So we are setting, then here with flag, with flag. Um, with flag. Then that's it. So it should be done. Let's do our optimizations. So moving it on top, we have our method. So we say if method equals null, then do that. And that's that. Here we are getting our, well, let me put a region here. Actually, meh. We are getting our property info here, and we can use property info here. So if property info equals null or not, property info can write. Then we have the field info, move it on top. Then we have the field info that we can use here. There we go. So then we have this. We say var property info equals to that. If property info equals null, or the property info that, property info dot that, and then we have the field info. So var field info equals to that. If field info equals null, otherwise field info dot get value. There we go. Okay. So obviously, instead of all these if and redefining variables, I could pull up that property info and field info all the way up at the start of the tick right here. For example, I could say cut, paste, then to hell with this, and then property info, cut, paste, and then we'll have one error somewhere here. To hell with that. Okay, now the thing is that regardless of our situation that we want a property or a field, we will call two things. I can do this. I can say a field info that, and then a property info that, so they are empty right now. Okay, then we say if our type equals to field, then I will get my field info equals to that, else I will get my property info. Like that. Okay, so this will at least unassigned, okay, equals to no, assigned. So this way, if I'm just working on something, I won't call reflection 2 times, and by the way, it won't happen unless you send in a wrong naming. So what are you saying now about this? Convert to switch. If you look, switch vs if else C#, there is this conversation and there is this explanation. And I don't know, I mean, I had heard Nelson not liking switches, but jump table, okay. And look up on that table. Well, 1 and has noticeable constant fast, but if number of case labels is large, it will significantly faster than comparing to each strings. To sum it up, if number of condition is more than 5 or so, prefer switch over if. Otherwise, you use whatever you like. Well, conditions here is 1 all the way here, 2, and that's it. Well, let's do that. I'm not sure. Let's do this. The problem with switch case is that I don't get this indentation, you know. Oh, let's do this. I don't know. Switch. So case get. Ah, I get the indentation. Case set. And then we have a case invoke, actually. So we break. And we have case invoke with a break. Case invoke is this guy. There we go. So that's our switch case. And because we are returning here, we don't need that. And that is that. Instead of breaking, I can return here so that in future, if I added something, I don't get derped. Now, that's one switch case. And now it yells at me to convert it to generate switch labels. Default. Yeah, what was that? Now, this if does not convert to switch. Okay? So, if we are filled, otherwise something. Yep. So, the next thing that I want to add here is this part, you know. Actually, instead of putting a try here, I can do this. I remove the try from here and put the whole thing in a try system. So even before this, I would say from here, a try, thank you, down to the end of this guy, to here, okay? And then I say catch without any exceptions, and I will say our state equals to earth, if any exception happened. And that would handle everything. So, with one try catch. So if anything anywhere is problematic, you will fall into error state. And then return. Good. And I'm very certain this will work this time. It's not like some of the methods that I had doubt about it. This is very straightforward. So region set variables. Regionifying just because it will help me close those regions like this, so that I can take a look at the reflection code itself if I want to. So that, and region, and that, and finally one more here. There we go. And now we can close it. So uh, this is the whole thing, you know. And that's it. Now, what are you saying at to expression body? To expression body. What would happen? It should work, I hope. Build. I'm a bit weary of expression bodies because if you recall, our dark skin was problematic, but I think this is okay. So, yep, we have our reflection node, and method result of course is not being used, but that's the result that the guy that using this node can pull it out. And why are you yelling at me? No, what to param? I don't want that. And I can't suppress it. Initialize film constructor, unassigned field. Forget about that. Thank you. Don't bother, please. There we go. So that's our reflection class, and let's take a look at over it. I wish I could collapse ifs. That would help a lot. Or switches. Something like that would be really neat. Let me take a look. Extensions. Something like that should be there. And we're close to 1 hour. Meh. So online collapse if no well easier way. Visual Studio collapse if blocks. There we go. And we have an extension there and 2 answers. Adds all braces outlined for C# editor. Yep, that's what I want, sir. C# outline. Is that? Well, it's what? Installed? Then what? Wait a minute. If it's installed, yeah. Well, let's take a look why it's not doing that. C# apply 2015. Well, why can't I do this? You derpy guy. I can't close my if. There's nothing here for me. There is nothing there for me, you know. No, it's not there. So, well, pausing the video, stopping the video, see you in next episode. Anyway, bye bye.